Hi everyone, I will solve 2018 question number 9. The tangential velocity component v of a spacecraft which is in a circular orbit of radius r around a spherical earth mu equal to gm gravitational parameter of earth is given by the following expression. A. V equal to under mu upon 2r. B. V equal to under mu upon r. C. V equal to 2 pi upon under mu r to the power 3 by 2. D equal to V equal to 2 pi upon under root mu r to the power 2 by 3. And this problem is related to spaceflight flight mechanics, two-body problem. So to know more about this two-body problem, you can refer to this NPTEL lecture. So in two-body problem, there are two bodies of mass m1 and mass m2, and both if we take the origin at mass m1, then position vector of mass m2 is given by r vector, this r vector, and this r vector makes an angle theta with this eccentricity vector whose magnitude is called eccentricity, and the velocity of this mass m2 is given by r dot or v vector. This r dot makes an angle gamma with perpendicular velocity, which gamma is called flight path angle. So when this angle theta is 0, this theta is called true anomaly. When this theta is 0, then the point at which the mass m2 was is called periapsis, and this line joining the periapsis and mass m1 is called f line. So if we write the equation of motion using the Newton's law of motion, we will get r double dot equal to minus mu upon r cube r vector. So r double dot is acceleration, and mu is gravitational constant for Earth, which is nothing g into m. G is the universal gravitational constant, and m is the mass of the Earth. If body m1 is Earth, this m, you can see m1. And so if we solve this equation and use the Kepler's law, we will get r equal to h square upon mu 1 upon 1 plus e cos theta. Here h is angular momentum, and e is the eccentricity. We can also find the perpendicular velocity to the position vector, which is given by v perpendicular equal to mu upon h 1 plus e cos theta, and similarly radial velocity is given by mu upon h e sin theta. So this e is the eccentricity. So for different conics there will be different value of e. So for circular orbit, value of this e is 0. So if you put value of e 0 here, this term will be 0. So we will get r equal to h square upon mu. Similarly, this perpendicular velocity, we put equal to 0, this term will be 0. We get v perpendicular equal to mu upon h. And here, if we put equal to 0, it will be 0. So radial velocity is 0. So net velocity will be equal to perpendicular velocity, which is mu by h. Now if you substitute h from here, so here you can find h equal to under root mu r. We substitute this h here, mu upon under root mu r, we will get it as under root mu by r. So it is only this. If we put equal to 0 in the orbital equation, r equal to h square upon mu upon 1 plus e cos theta, it will give r equal to h square upon mu. and velocity of the circular orbit is given by under root mu by r. So the answer of this problem is v equal to under root mu by r, which is the tangential component of velocity, or you can say total velocity also, because radial velocity component is 0. Answer is B.